All right, welcome. We're here doing another LeetCode problem. We're going to be solving the insert, delete, and get random of one. This is LeetCode problem 380. It's a medium, so we're going to dive right in. So the problem is as such: implement a randomized set class. We should have an insert where it inserts a value if the set's not present. Return true if it's not present, false otherwise. Remove the value if it's present, return true if the item is present, false, and get random. Return a random element from the current set of elements if it exists, and it has to have the same probability of being returned. And everything, here's the key. Here's the key of how to understand this problem. You must implement the functions of the class such that each function works an average big O of one complexity. So looking down here, you can see you create a set, you're inserting one, removing two, you have true, false, there's not a two. You insert a two, true, get random, get back two, remove a two, true, insert false, get random, two. So this is pretty much how to think about it. When you see a get random in the same probability, that means you're going to have a random class or object here. We'll create some private variables. So in order to solve this problem, the main function comes down to figuring out how to make this work an average big O of one complexity. Um, if you were to do a hash map alone, which is the first data structure that comes to mind, that's great because you can insert an O of one, remove an O of one, but you can't get a random value through there with the same probability. Because we're going to be needing to calculate random indexes basically. So hash map sort of works. If we can combine another data structure with this, then it will work. So what if we created a hash map where the key equals the values we're adding and the value for the key value pair equals the index of insertion of that said value. So we'll also create a list so we can access the elements and remove. We want to basically access the elements randomly via this and then update both this list and the hash map with the inserts and the removals. So create a hash map, make it private list, integer list, and the constructor will initialize these. We're going to create an array list. Okay. So now that's done. We have the constructor done. So we need to get into the insert method. So the insert says return, says insert an item val into the set if not present. Otherwise, turn false. So if the map contains the key that we're looking for, val, return false because it already contains. Otherwise, we need to add it. So we'll just simply put it, the put method, and For the value, since we're going to be using a key value pair, the key being the number we're trying to add, and the value will be the index of this element in the list, we can just do list size here. Because when it starts out, list size will be 0, and as it goes on, it keeps track of the index, if you follow that. And then we return true. Let's pop down to the GetRandom here really quick. So the list is containing the values and each corresponding index position in the list is what we're going to be referencing. So if we want to get a random, all we have to do is return the list.get rand.next int, and we want to specify the bounds of the random. When you say rand.nextInt, it can go 0 to maximum integer, or you can give it a bound. So we're going to give it the bound of the size of the list so we don't go out of bounds. And that should work there. Now we got to remove. This is kind of where it gets tricky. So first we'll just check and see if it even contains it. So if the map doesn't contain the key, we're going to return false because we can't remove anything that doesn't exist. And now we actually have to remove. We want to remove and update both the list and hash map accordingly. We want to update the targeted removal value with the value at the end of the list, switching their indexes. So the reason I'm switching the indexes is you could theoretically just remove this, but we need it to be O of 1. So that means that we can't just do the remove method on the list because it would sift through, recreate it. That's O of n. So we need to be a little bit more granular with how we approach this. So first we can get the index that we want to delete. And that will be in the map because the map has the values tied to the index location in the list. So now we have the index that we want to delete. Let's get the last index. And this is just merely list.size minus 1 because of we're starting from 0. And then we're going to get the last value. And this will just be list.get last index. Okay, so now we kind of have our variables to do. And now what we're going to do is update the map, update the map's last value with the or update the map's value to remove with the last value. So we'll merely put the last value at the spot where the index to delete is. So we're updating the hash table. So basically the hash table now has replaced the value we're deleting with the last value in the list, okay? And then now we want to set the list, so we're going to update the list too. So we're going to set the location of the index to delete. We're going to set that to the last value. And then we're just going to remove the value from the map. And we'll remove the last value from the list. And Let's give it a double check. Give it a run. Ah, forgot to return here. All right, so we passed. Let's see if we can pass all the test cases. Okay, so we passed and we beat 93.42% complexity and runtime and 79% on memory. And this is O of 1 and O of, this should be O of 1. Or O of n because we're going to be utilizing the hash maps. So that's the problem. The main things to note as well are when you're doing the GetRandom, you need to utilize the list, not the map, because the list is holding, the list gives you access to the indexes. So we can use random in order to get that. From a hash map, we cannot do that because there's really not a good way to iterate that. And then here, this is kind of the trickiest method, I would say. Logically, all you really are trying to do is you're checking to see if the value exists right here. And then you're getting the index that needs to be removed. Then you're getting the last element of the list and the last index. And then you overwrite the element to be removed with the last value. And then you remove the last element. So hopefully this is beneficial. It's a little bit harder, in my opinion, just a little bit tricky to figure out how to wrap your head around things. But the main thing is when you're looking at this problem, when you see O of 1, you should immediately start thinking about hash tables, hash sets, the data structures that can accomplish this. And then when you see the random, you know that you might need another data structure in order to accommodate this. So by combining hash tables with array lists, you can get this type of functionality where you have, O of 1 insertions, removals, and the ability to randomly navigate this. Hope it was helpful, and good luck.